Welcome to Chapter 1 of Class 10 Science, Chemical Reactions and Equations. In this exciting chapter, we'll explore how substances transform into new substances through chemical reactions. We begin with a quote from Martin H. Fisher: "Facts are not science as the dictionary is not literature." This reminds us that simply knowing facts isn't enough, we need to understand the processes behind them. Throughout this chapter, we'll investigate chemical changes happening all around us, from burning magnesium to rusting iron. We'll learn to identify chemical reactions, write and balance chemical equations, classify different types of reactions, and understand important concepts like oxidation and reduction. Get ready for an amazing journey into the world of chemistry. Let's begin by learning how to identify chemical reactions. How do we know when a chemical reaction has occurred? Look for these telltale signs: change in state, change in color, evolution of gas, change in temperature, or formation of a precipitate. In Activity 1.1, we burn magnesium ribbon and observe it burning with a dazzling white flame, producing white magnesium oxide powder. This shows both change in state and change in color. In other activities, we'll see lead nitrate and potassium iodide forming a yellow precipitate, and zinc reacting with acid to produce hydrogen gas bubbles while the test tube becomes warm. These different signs help us recognize that chemical reactions are taking place. Chemical reactions are happening all around us. When milk turns sour, when iron rusts, when food cooks, and even when we breathe. Now let's learn how to represent chemical reactions using equations. We can describe reactions using word equations, like magnesium plus oxygen yields magnesium oxide. But chemical equations are more precise. Using symbols and formulas, Mg plus O2 yields MgO. Chemical equations have reactants on the left side of the arrow and products on the right side. The arrow shows the direction of the reaction, and plus signs separate multiple reactants or products. For example, zinc reacting with sulfuric acid is written as Zn plus H2SO4 yields ZnSO4 plus H2. However, we need to be careful. The equation Mg plus O2 yields MgO isn't balanced yet. If we count the atoms, we have 1 magnesium and 2 oxygen atoms on the left, but only 1 magnesium and 1 oxygen atom on the right. The oxygen atoms don't match. This brings us to our next important concept: balancing chemical equations. Balancing chemical equations is essential because of the law of conservation of mass, which states that mass can neither be created nor destroyed in a chemical reaction. This means the total mass of reactants must equal the total mass of products, and the number of atoms of each element must remain the same. Let's balance the equation for iron reacting with water vapor. We start with Fe plus H2O yields Fe3O4 plus H2. Counting atoms shows iron, hydrogen, and oxygen are all unbalanced. We balance oxygen first by putting coefficient 4 before H2O. Then we balance hydrogen by putting coefficient 4 before H2. Finally, we balance iron by putting coefficient 3 before Fe. Now we have 3Fe plus 4H2O yields Fe3O4 plus 4H2, with all atoms balanced. We can also make equations more informative by adding physical states: solid S, liquid L, gas G, or aqueous AQ. Chemical reactions can be classified into different types based on how reactants transform into products. In combination reactions, 2 or more substances combine to form a single product. The general form is A plus B yields AB. When calcium oxide reacts vigorously with water to produce calcium hydroxide, This is both a combination reaction and an exothermic reaction that releases heat. Burning coal, formation of water, and respiration are all examples of combination reactions. In contrast, decomposition reactions involve a single substance breaking down into two or more substances. The general form is AB yields A plus B. When we heat green ferrous sulfate crystals, they break down into ferric oxide, sulfur dioxide, and sulfur trioxide. This is called thermal decomposition since it's caused by heating. Combination reactions build up substances, while decomposition reactions break them down. Let's explore two more important types of chemical reactions: displacement and double displacement. In displacement reactions, one element displaces another element from its compound. The general form is A plus BC yields AC plus B. When an iron nail is placed in copper sulfate solution, the iron becomes brownish as copper is deposited, and the blue color fades. This happens because iron is more reactive than copper. The reactivity series helps us predict which elements can displace others. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, silver, gold. More reactive elements can displace less reactive ones. In double displacement reactions, there's an exchange of ions between reactants. The general form is AB plus CD yields AD plus CB. When sodium sulfate reacts with barium chloride, a white precipitate of barium sulfate forms. Any reaction that produces a precipitate is called a precipitation reaction. Now let's understand oxidation and reduction reactions, which always occur together in what we call redox reactions. Oxidation involves gain of oxygen or loss of hydrogen, while reduction involves loss of oxygen or gain of hydrogen. When copper powder is heated, it turns black as copper oxide forms, copper is oxidized, and oxygen is reduced. We can also define these in terms of electron transfer. Oxidation is loss of electrons, reduction is gain of electrons. In the reaction between zinc and copper sulfate, zinc loses electrons to form zinc ions, while copper ions gain electrons to form copper metal. The substance that gets reduced is the oxidizing agent, and the substance that gets oxidized is the reducing agent. In redox reactions, oxidizing and reducing agents always work together. One cannot exist without the other. Oxidation has important effects on our daily lives, particularly through corrosion and rancidity. Corrosion occurs when metals are gradually eaten up by air, moisture, or chemicals. Rusting of iron, tarnishing of silver, and green coating on copper are all examples of corrosion. Rust is hydrated iron oxide that forms when iron reacts with oxygen and water. Corrosion causes huge economic losses worldwide. We can prevent it through painting, oiling, galvanization, chrome plating, anodizing, or alloying. Rancidity is the oxidation of fats and oils in food, resulting in bad smell and taste. Potato chips becoming stale or butter developing bad odor are examples. We prevent rancidity by adding antioxidants, packaging in nitrogen gas, refrigeration, or storing in airtight containers. Understanding these processes helps us preserve food and protect infrastructure. Let's review the key concepts from this chapter. Chemical reactions are processes where new substances with new properties are formed. Chemical equations are concise representations using symbols and formulas. Balanced equations have equal numbers of each type of atom on both sides. We've learned about combination, decomposition, displacement, double displacement, and redox reactions. We've seen how oxidation affects our lives through corrosion and rancidity. Important equations include magnesium burning, calcium oxide with water, decomposition of ferrous sulfate, and various displacement reactions. Understanding chemical reactions helps us in food preservation, infrastructure protection, manufacturing, medicine production, agriculture, and energy generation. Chemical reactions are fundamental to our modern world. Thank you for learning about chemical reactions and equations with SilentReader Science. We hope you enjoyed this journey through the fascinating world of chemistry. Remember the key takeaways. Chemical reactions transform substances. Balanced equations follow conservation of mass. Different reaction types have unique characteristics. Redox reactions involve electron transfer, and oxidation affects our daily lives. In our upcoming videos, we'll explore acids, bases and salts, metals and non-metals, carbon and its compounds, and much more. Subscribe to our channel, like this video if you found it helpful, comment with your questions, and share with classmates. As Marie Curie said, nothing in life is to be feared, it is only to be understood. Keep curious, keep learning, and keep exploring the wonderful world of science with SilentReader.